All right, number 4 on the Unit 2 review is kind of a long one. First of all, we have to determine whether y equals the square root of the absolute value of x is continuous. So just like with other absolute value problems, we need to separate this into two possibilities. So we have, in this case, x less than 0 and x greater than or equal to 0. You can put the equal to on either one, because this is where the sign would change. If x is less than 0, x is negative. If x is greater than 0, x is positive. So if x is less than 0, the absolute value is going to take the opposite of the sign. So that will actually come out positive, because the opposite of a negative is a positive. And if it's positive, then you don't have to change anything. It'll stay square root x. Alright, so to prove that it's continuous, the first thing you've got to do is find f of 0, which is the square root of 0, which is 0. And then if you check both limits from the left and the right, you will get 0 for both of them. So, since the limit is equal to the actual value, yes, it is continuous. Alright, so that's a good thing. We can't really do the second half of the problem if it's not continuous. Or maybe it's not a good thing, because that means we have to keep going. But now we need to do whether or not it's differentiable. So it's continuous, so it could be differentiable. We just have to check to see if the limit exists. Alright, so we need the limit as x approaches 0 from the left of the using the definition of the derivative, which would be f of h plus x, f of x plus h, and x is 0. Oh dear, that's supposed to be an h, excuse me. Too many zeros going on. Alright, so f of 0 plus h minus f of 0 over h. So that's just a fancy way to say the derivative of the function at 0. Alright, and that's using the left side. So that means we need to take the derivative of the left side to find that answer. So we're not going to use the long definition, we're going to use the shortcut. So the derivative of that is 1/2. Hold on, let me not skip any steps for you. Alright, so that can be rewritten as negative x to the 1/2. Right? So the derivative of that is 1/2 negative x to the negative 1/2, power rule, times the derivative of the inside, and the derivative of the inside is negative 1. So I'm just going to make that negative. Oops. And I need the derivative of at 0. So if I rewrite this, it's negative 1 over 2, square root of negative x. So I moved this to the denominator, and I put the 1/2 back to a square root. Alright, and so this is the derivative of the left side derivative, and I need the derivative at 0. Well, if I plug in 0, I get 2 times the square root of 0, which is the square root of 0, which is 0, so I end up getting negative 1 over 0, which is undefined. So if the slope is not defined, right, that's a problem. If the slope is not defined, then it is not differentiable. So we don't even need to bother doing the right side. The same thing will happen when we do the right side, but if one of the sides is undefined, the whole thing is undefined. So not differentiable. Alright, and if you want to know what that looks like, it's this cusp graph. So you see right where it cusps right there, it gets